What up guys, welcome to the first video of the SpideyPhysics Classical Mechanics series. Today we got a quick video just going over the calendar and table of contents, what we're going to cover with this course. Let's start with the calendar first. Alright, check it out. This is the calendar of classical mechanics. January, February, March, April. These little black squiggles are exam time, midterm semester break right here, Christmas break right here. So we start off chapter 1 and 2 or whatever, next section, next section, next section, next section, next section. Each alternating color is a different section. In January, you got to learn one-dimensional, two-dimensional motion, and vectors. In my 9th edition book of Survey and Jewett, that corresponds to chapter 2, 3, and 4. February, forces, Newton's laws, circular motion, work and energy, 5, 6, and 7. March, you get a break over here after learning all of this and all of this, which is quite a lot of content. So this break here is for you to kind of like absorb all this shit and use it on the midterm exam, which is going to be somewhere around here. Normally professors don't include work and energy in the midterm because this stuff beforehand is quite a lot, and then work and energy leads into this other kind of way of solving problems. So work and energy probably won't be on the midterm, but everything from here this way, learn it for the midterm exam. After that, chapter 8, 9, 10 in my version, conservation of energy, momentum plus collisions and torque, and then the last sections here and here, completing the course, rotational and static equilibrium, angular momentum, and simple harmonic motion, chapters 10, 11, and 12. So all of this content here and here is for the midterm, which is here, and all of the content here is for the final, which is going to be here. All right, so I have the table of contents and notes and stuff over here in a note in this app called Obsidian. You can see I have a picture of the 9th edition, pretty much the same shit as the 10th edition, don't stress about it. Here is the title of the book, and here we have the content. So I've split it up. The first chapter is not covered in our course, but it is important. I'm probably going to talk about it a little bit. Then we have chapter 2, 3, 4, 5, 6. These are going to be for the midterm. So we're going to cover this in the first 2 months or so of the course, a month and a half. This course here, or this chapter, is split up. Half of it is taught in the midterm portion, half is in the final. Most of the time they include this in the final exam portion because it pairs nicely with this conservation of energy chapter. So this thing might be covered roughly in the middle of a midterm break if we take something like this. Then here we have chapter 8, 9, 10, 11, 12. These will be covered for the final exam, and we have 2 more chapters that are not going to be covered in our course but are still pretty cool. You could check them out if you want. So let's take a look. Physics and measurement is the first chapter. Motion in 1 dimension, vectors, motion in 2 dimension. The laws of motion, circular motion and other applications of Newton's laws, energy of a system, conservation of energy, linear momentum and collisions, rotation of a rigid body about a fixed axis, angular momentum, static equilibrium, and elasticity. Very cool. So here I have everything broken down, all the chapters listed out in little like sections, and I've taken some notes in here. So you can see all my little notes. If you want, I can discuss this in a future video. But let me break down, I'm going to collapse everything. You can see the sections of the first chapter. 1.1 standards of length, mass, and time, matter, and model building. Conservation of units, or sorry, conversion. 1.4 conversion of units. 1.5 estimates and order of magnitude calculations, significant figures. And then we have chapter 2, motion in 1 dimension. Position, velocity, and speed, instantaneous velocity and speed, analysis model, particle under constant velocity, acceleration, motion diagrams, analysis model, particle under constant acceleration, free-falling objects, kinematic equations derived from calculus, and chapter 3, vectors. Coordinate system, vector and scalar quantities, some properties of vectors, components of a vector and unit vectors. I put over here a video that I posted a while ago called Vectors and Their Algebra. I cover a lot of stuff here, so maybe this vectors chapter I'll go through pretty quickly. Then we got chapter 4. the position, velocity, and acceleration vectors, two-dimensional motion with constant acceleration, projectile motion, analysis model particle in uniform circular motion, tangential and radial acceleration, relative velocity, and relative acceleration. Chapter 5. Over here I haven't started to take notes, so it's just like small list of the topics. The concept of force, Newton's first law in inertial frames, mass, Newton's second law, the gravitational force and weight, Newton's third law, analysis model using Newton's, this probably was equations of motion, I just did not write it down. Let's see, chapter 6. Extending the particle in uniform circular motion model, non-uniform circular motion, motion in accelerated frames, motion in the presence of a resistive force. Cool. Energy of a system. This is the last thing that you will learn before the midterm, I believe. Systems and environments. Work done by a constant force, the scalar product of two vectors. Work done by a varying force. Kinetic energy and the work kinetic energy theorem. Potential energy of a system. Conservative and non-conservative forces. Relationship between conservative forces and potential energy. Energy diagrams and equilibrium of a system. Chapter 8, analysis model, non-isolated system, energy, analysis model, isolated system, energy, situations involving kinetic friction, changes in mechanical energy for non-conservative forces, power. Chapter 9, linear momentum, analysis model, isolated system, momentum, analysis model, non-isolated system, momentum, collisions in one dimension, collisions in two dimensions, the center of mass, systems of many particles, deformable systems, rocket propulsion. Awesome. Rocket propulsion is pretty cool. Rotation of a rigid object about a fixed axis, chapter 10. Angular position, velocity, and acceleration, analysis model. Rigid object under constant acceleration, angular acceleration. Angular and translational quantities, torque. Analysis model, rigid object under a net torque. Calculation of moments of inertia. Rotational kinetic energy. Energy considerations in rotational motion. Rolling motion of a rigid object. Second last chapter, chapter 11, the vector product and torque, analysis model, non-isolated system, angular momentum of a rotating rigid object, analysis model, isolated system, angular momentum, the motion of a gyroscope, and tops. Last chapter, chapter 12, analysis model, rigid object in equilibrium, more on the center of gravity, examples of rigid objects in static equilibrium, elastic properties of solids. So that's everything. I kind of just wanted to zoom through very quickly so you guys can have a feel of what we're going to cover. I know it's a lot of content. I just read for like 3 minutes straight, but don't stress. You kind of want to look at this every now and then to see like, where am I at? How am I positioning myself? Check out the calendar video as well. And, you know, keep reading the table of contents, keep reading the book, and I'll see you guys in the next video, which will be the first video of this series. Probably we're going to start off with physics and measurement. And let me know if you guys want to see anything specific. Thank you for watching. Peace out.